the current research that I'm working on. I call it robust GUI-based test automation. That's the goal of creating. GUI-based test automation is, of course, my field. Work. So I actually got the recommendation from my supervisor to not place everything into one slide. So I decided that I won't do it. These are the challenges that we found in an SLR that we started before BC, before COVID. This is the outcome of the SLR. So there are a number of challenges within the GUI test automation area. And these are the biggest ones, according to that SLR. And we divided them into essential and accidental. And accidental are challenges that we actually can do something about. And essential are challenges that, yeah, they will remain the same, or they will remain, and we cannot really mitigate them completely, or maybe at all. So we need to focus on the ones that are accidental to the right here. So with the previous tool, you saw actually a bit of that tool recently. That was not the intention, but that was Scout. And a couple of papers before BC, actually, we targeted those challenges. That is, that you require test automation skills in order to create good test cases, automated test cases, obviously. Also, the problem of maintaining test cases after you have created them is a big problem because it costs a lot of money. So we targeted that before. In the future, upcoming papers, I will target also the synchronization and timing issues. You know, when you are running test scripts, especially on a UI level, you get the problem that the test script needs to wait before performing an action, because it takes some time for the UI to update and the application to be ready for the next click or input. And we have to slow down the test execution. Otherwise it will fail. Otherwise it will waste the click before the button even appears on screen. So that's upcoming research. And today we are focusing on the robust identification of, I call it widgets here because that's a more general term, but in a web application, it's web elements like buttons and lists and stuff. This is an example. So now some porn for some. So this is an example with test code for implemented in Java with Selenium WebDriver. You recognize it? Some, yeah. And we have a simple form, very simple form. And this script actually starts the web page. It fills out the form with some values, a lot of values about myself, and then presses the send message button and then verifies that the next screen appears. So this is a typical fabricated test case. But you see, in all of these test cases, there are a lot of find elements, as you can see here. It contains a lot of find elements, and that's finding the elements to interact with. Like if you want to enter a value into a field, you need to first find it, localize it. If you want to click the send message button, you need first to find it, localize it. And the find element function in Selenium takes a parameter, and that can be any of the 7 or 9 different locator types it has. We can see some of them here, by link text, by ID, by tag name. There are also by XPath, by CSS, and some more, by class. And if they change, like in a new version, like this application is maintained all the time by the developers, the dark side, and they make changes, maybe without even telling the testers, and suddenly this breaks the test cases because they changed the ID, they changed the text, not to send message, but instead to submit message instead, and it breaks because it has changed. So that's a problem, and that requires maintenance and, of course, a cost that is unnecessary. So this cost we're trying to avoid. That's our goal, to make it more reliable, to less sensitive. So here we have an application that you have all used, I guess, YouTube. We have an older version to the right and a newer version to the left. And now it's a good thing that we have a big screen here. But I put a rectangle around the ones that are in common. The buttons or web elements that I believe as the Oracle exist in both the old version and the new version. And you see they are also color coded. So all the rest are like, other stuff that is not in common. But still, there are like 3 years in between these versions, and you see that there are still like 8 things that are in common. If we look at the history button here, we look more closely into that, and we take a few of the tags here, and not all of them, there are plenty more, but the tag is obviously the same between versions, between the old version and the new. Text is still history in both versions, but we can see here that the XPath, you all know what the XPath is? Otherwise you Google it. No. So the XPath has actually changed from the older to the newer version. You see that it starts the same, which an absolute XPath always starts with HTML. So obviously it starts. The ID XPath is also different, and the older version doesn't have a class element. So they are a little bit different and a little bit of the same. So this is where our proposed algorithm comes in, or approach. And we call it similarity-based GUI web element localization, or SIMILO for short. And that's the paper that we will try to publish soon. It actually it takes 2 sets of web elements. One candidate web elements, that is the ones in the newer application, all the elements, all the possible web elements that is in the application. And it also takes the locator properties from the ones that we want, to find at the target, and compares all of them, all the properties with each other, and creates a similarity score. And in the end, it picks the one with the highest similarity. And that's hopefully the right one. In the case of the history button, it would be the history button. That would be the correct one. So it compares, in this case, 14 different. And these ones we have selected based on experience. We have also selected ways to compare it. Like, for example, the tag of 2 elements is compared by equals only. So it's a 1 or a 0. For XPath, they're more complex, but an XPath can be almost the same, right? And that's probably better than it's completely different. So in that case, we have used Levenshtein distance instead. And that instead returns a value between 0 and 1 for the similarity. And then all of these are weighted also because they are not equally important. So some are more reliable than others. And in our case, we have also that based on experience for now, but we are trying to, in future studies, to improve this, to actually calculate it. But that requires a lot of performance. So how did we do this? Yeah, the methodology for it, we selected 40 websites. That is the 40 top websites used in US. And it's listed on alexa.com. And we took 2 versions using the Wayback Engine. Have you used it? Yeah, it's good, but it's really slow and unreliable. So we have had a lot of problems with it because of the slowness. But we picked one version from the end of 2020, and then a random number of months older than that, between 12 and 60 months, actually. So in the Google, which is of course the most commonly used web application, no surprise, and YouTube was the runner-up. So it was, yeah, about 2 years. And then we picked out the target web elements, and in both that are like, yeah, the Oracle things, is the same, and picks out the absolute XPath to it, since that is like a unique identifier. The one in the newer is used as an Oracle, and the other one is used to pick out the properties. And this is the part where we want to fetch the properties and also locate it to see if it works. So going this flow, we start by taking the XPath of the candidate or the target in the old version, finding all the web elements, creating locator parameters, the 14 you saw in the comparison algorithm, feed it to Similo and ask it to find the most similar one, and then take the XPath from that and compare it with the Oracle and see if it matches. And if it matches, then 1 point to Similo. And then we did also the same thing with the baseline approach. And the baseline approach in this case is the Leota multi-locator that we selected for the baseline approach. And it uses a number of single locators. I will not go into detail in this time. You have to read the paper for that. And the results. So the important results are between the multi-locator and Similo in the end of this table. The other ones are the single locators. The multi-locator is actually using the single locators and the voting mechanism to find the other one. So that it's always better than the rest of the single locators. But basically, the first 3 is state of practice. The second 3 ones are state of art, and Similo is our proposed solution. So you see that it has half amount of non-located, which is the important thing, because that's the thing that causes maintenance of the test groups. So if you have 24 that you have to maintain, that takes about, in average, double the time of maintaining only 12.
And just quick clarification, in total there were 598 widgets taken from the 40 applications that you saw previously.
Yeah. So this result shows that Similo is more more robust and therefore requires less maintenance, which is good. The optimal value is of course 0, but we don't know if we will reach it, but we will make another try and try to actually reach closer to zero. And one of them is something that works that we'll do together, Coppola and I, perhaps. And I call it Similo++, but it doesn't have a name yet. And it might also use a neural network instead. So we'll train a big neural network with the data and see if it's better than Similo on picking out the right one. Another thing that's also for the future is of course to address the challenge that we haven't addressed yet for GUI-based test automation, and that's the reliable way of finding the next GUI state. Now we have clicked and now the screen is stable. Now we can click again. So the synchronization challenge.